Okay, hello guys, we're going to continue with what we started in class about Avogadro's number. We said that Avogadro's number is the number of atoms in 1 mole of atom, or the number of molecules in 1 mole of this molecule. So Avogadro's number, that is Na, is equal to 6.02 times 10 to the power 23 atoms. Okay? Now, we have, for example, carbon with a smaller mass, or with its mass that is 12 and its atomic number, or Z, that is 6. Okay, so C12,6 is XAZ. A is equal to 12. We can say that the molar mass of this atom is 12 grams. We put these 12 grams in a box and we name them 1 mole because we took carbon as a standard in chemistry. Okay, so it is a standard or a reference in chemistry. So 12 grams is equal to 1 mole is equal to 6.02 times 10 to the power 23 atoms. So this 1 mole contains 12 grams, which is 6.02 times 10 to the power 23 atoms, okay? The mole is the unit that we use to express the quantity of matter. How much matter we have is the mole. We will explain previously in the coming exercises about this. For example, C12,6, 12 gram is the molar mass, okay? 12 AMU is the mass of one atom, atomic mass. So when I'm asking about the atomic mass, the answer is in AMU, atomic mass per unit. So 12 gram, it is 12 AMU, okay? Consider 12 gram of carbon, which is the molar mass. It contains atoms very big. This 12 gram contains very big number of atoms since it exists in nature as an atom. So we can say 12 gram is the molar mass that contains 6.02 times 10 to the power 23 atoms. We put these 6.02 times 23 atoms in a box and we name these as 1 mole, okay? Molar mass is the mass of 1 mole since 1 mole is Na, is 6.02 times 10 to the power 23 atoms. So, molar mass is the mass of 6.02 times 10 to the power 23 atoms or molecules. When we talk about the representation of an atom, we talk about XAZ, where A is the molar mass, it's in gram. Example, Na 2311. 23 is the molar mass, so it is in gram per mole. Per mole because 23 grams in this mole atom, okay? So, another example is Ca420. The molar mass is 40 gram per mole. 40 gram in this mole, in this calcium mole, in this 1 mole of calcium, okay? Now, here are some rules that we're gonna use in this lesson. The mass of an element, that is M, and the quantity of matter, that is N. Okay, N and M. N is the number of moles. Its unit is mole. Okay, its unit is mole. Just a second to take my pen. Okay, so N is the number of moles. Its unit is mole. M is the mass in gram, and M capital or capital M is the molar mass in gram per mole. So the first rule is N equal mass, here it is, N equal mass over molar mass. N is in mole, M is in gram, capital M is in gram per mole. Another rule for the quantity of matter, that is N, okay, is capital N over Na. So N can be mass over molar mass or capital N over Na. Capital N is the number of atoms or molecule. Whenever I ask you about the number of atoms or number of molecules, I want you to calculate capital N. So, Na is Avogadro's number that you already know, 6.02 times 10 to the power 23 atoms. So, small n equal capital N over Na, or small n equal mass over molar mass, okay? Example. What is the molar atomic mass of argon such that the mass of 0.05, here it is, such that the mass of 0.05 mole atom of this gas is about 2 grams. Look here, the first thing I do before I start calculating any exercise is put the information that he gave me first. What information I have in this text? I have 0.05 mole, that is a small n. This is the quantity of matter, its unit is mole. So he's talking here about small n. And he gave me 2 grams, that is the mass. So here I have number of moles, that is n, and I have m, that is the mass. The rule says n equal mass over molar mass. If I want to calculate molar mass equal, I keep here the mass in its place and I bring down the n. So mass over n, mass over number of moles. So the mass here is 2 grams. The number of moles is 0.05. So 2 over 0.05 is 40. The mass is in gram. The number of moles is in mole. So the unit is gram per mole minus 1. Okay? Now, another example. Given 25.4 gram of copper, Cu. Calculate the number of moles of copper. He gave me the molar mass. And he gave me here the mass. This is point, okay? I have here the mass and I have here the molar mass. So n equal mass over molar mass. Mass is 25.4 over molar mass, that is 64. So 25.4 over, this is 4, over 64 is 0.396 mole. On your calculator you have 0.36, 0.396 and many other numbers. You only take 2 or 3 numbers after the point, okay? So 0.396 mole. In part B, he's asking you to deduce the number of atoms in the given sample. Deduce the number of atoms. He's talking about capital N. The rule says, we go back to the rule, small n equal capital N over NA. He wants this. I have the small n that I calculated in the previous part, and NA I know it's 6.02 times 10 to the power 23 atoms. So small n equal capital N over NA. N equal n times NA, crisscross method. So n is 0.396 times NA, 6.02 times 10 to the power 23. And here, to make the calculation simple, I calculate 0.396 with 6.02. It gives 2.383. I bring down the 10 times 10 to the power 23 atoms. So I don't put this in the calculation. I just drag it down beside the number that I calculated. So 2.383 times 10 to the power 23 times 10 to the power 23 atoms. Okay? When we're talking about the charge of the atom, we're talking about Q of the atom. So Q is the charge of the atom. And when we're talking about the atom is made up of the nucleus and the electron cloud, okay? Atom is made up of the nucleus and the electron cloud. When we're talking about the charge of the atom, it's equal to the charge of the nucleus plus charge of the electron cloud. When we're talking about the nucleus, charge of the nucleus is made up of protons and neutrons. Here we have neutrons. Q of neutrons. Q of neutrons is equal to 0 since the neutrons, they don't have charge. So it is 0. So charge of the nucleus is the charge of the protons. Charge of the nucleus is equal to the number of protons times the charge of one proton. Number of protons is Z, the atomic number, and the charge of the protons is plus E. So let's take an example. Charge of the nucleus of chlorine. Z of chlorine is 17, that is the number of protons, times the charge of the proton, charge of one proton. So 17 times charge of one proton is 1.6 times 10 to the power minus 19. You can memorize it, but it's most of the time given to you. So again, we calculate 17 with 1.6, it gives 27.2, and we drag down times 10 to the power minus 19, again to make the calculation simpler, okay? Now, when we're calculating the charge of the electron cloud, since we already know that charge of, let me put here, neutrons. Okay, we already know that the charge of the that the number of electrons is equal to the number of protons in a neutral atom. So when I put in a neutral atom number of protons is equal to the number of electrons, Z equal atomic number equal number of protons, I can put instead of the number of electrons Z. So charge of the electron cloud is equal to the number of electrons times charge of an electron. So number of electrons is equal to the number of protons is equal to 17 times charge of the electron is not 1.6 times 10 to the power minus 19, it is minus 1.6 times 10 to the power minus 19 since electrons are negatively charged. So we calculate 17 times minus 1.6 is minus 27.2, and we drag down the minus 10 to the power minus 19, okay? So the answer is minus 27.2 times 10 to the power minus 19. C is coulomb, the unit for the charge. So charge of the electron cloud is minus 27 times 10 to the power minus 19. Charge of the nucleus is 27.2 times 10 to the power minus 19. And when we go back to the charge of the atom, it's equal to the charge of the nucleus plus charge of the electron cloud. So 27.2 times 10 to the power minus 19 plus charge of the electron cloud, that is minus 27.2 times 10 to the power minus 19. The answer is 0 coulomb. Yes, since an atom is a neutral, that is, it has no charge, okay? An atom is a neutral, it has no charge, its charge is 0. I want you to copy all what I explained today on your copybook so that we continue our explanation on Thursday. So on Thursday, we're gonna take chemistry and not biology to solve more exercises since these are included in your exam on Monday. Okay? Good luck, guys. See you. If you have any question, don't hesitate to contact me. I told you previously about this. Have a calm night and see you on Thursday.